Hi, I am 3 honor students. It's Miss Mack here, and today we are going to do section 7.7 operations with radicals. So we're going to start with simplifying radicals, and we'll move on to adding and subtracting radicals. So let's review how to simplify a radical. So for our first example, we are going to simplify, and let's simplify something like the square root of 80. Okay, so what do you do here? You find the biggest perfect square inside of 80 that's a factor of 80. And so if you don't know your perfect squares, you should lift them off to the side, but hopefully you're good at them by now. 4, 9, 16, 25, 36, 49, etc. Okay, and what is the biggest perfect square you can find inside of 80? If you think the answer is 4, you haven't found the biggest one. And if you use 4, you'll have to do the problem twice, essentially, or the work involved twice. So I would use the biggest perfect square, and that would be 16. So we would change 80 to 16 times 5. Okay, and then you would have the square root of 16 times the square root of 5, and the square root of 16 is 4. So the answer is 4 root 5. So you have done that before, but just kind of a review of how to simplify a radical. Now for B, let's do the square root of 243. Now that's a much bigger number. So you may need to go to your list and keep going. I'm not sure. It's up to you what you need to do, how many numbers you need to find. Can you find a perfect square inside of 243? So take a moment, see if you can do that. If you know what you're doing, then I would do this as a try it, see if you get the answer right. Pause the video and come back. Otherwise, if you need some help, keep watching. So 243. So what you can do if you don't know the perfect square that goes into it is you can just try a bunch of them. I like to try the list going up instead of going down because then I'll find the biggest one first. Okay. And I like to start halfway. So if I divide 243 by 2, I will start at around 121. So 10 times 10 is 100. 11 times 11 is 121. Now I know 121 isn't going to go into it because there's a decimal there. So if I keep going up this list, I could try 243 divided by 100, but I know that is not the answer. So then I would try 243 divided by 81, and it goes in 3 times. So there, I've found my perfect square that goes into 243. So I would break this up into 81 times 3. That would be the square root of 81 times the square root of 3. And we know the square root of 81 is 9. So your answer would be 9 root 3. Okay. And what happens if there is a number out in front? So let's try that. So for C here, let's make it 3 square root of 98. Okay, go ahead and pause the video, try it on your own, and come back and see if you get it right. You need to know the biggest perfect square that goes into 98. And there are 3's still out in front. And this is 49 times 2. So that is 3 times the square root of 49 times the square root of 2, which is 3 times 7 times the square root of 2. We don't put a dot here because they're next to each other. We know it's multiplication. And then 3 times 7 is 21 root 2. Now, if you don't like dots, you could also use parentheses here. Totally up to you how you write that. Your answer is 21 square root of 2. So that is simplifying radicals. Let's simplify a radical, but this time the radical might have addition or subtraction. So let's look at example 2. In example 2, we have simplify 4 square root of 200 minus 3 square root of 72. Okay, now this problem is a little different than what we've done before because we cannot add or subtract radicals unless they have the same index and the same radicand. So the index and the radicand need to be the same if you want to add or subtract radicals. So the number here on your radical and the number inside your radical have to be the same if you want to add or subtract. And here they are not the same. So what we do first is simplify and see if we can make them the same. So we simplify the same way we did above. Simplify the one on the left, simplify the one on the right, and see if you can combine them at the end. So here we would have 4 square root of 100 times 2, which would be 4 times 10 root 2, or 40 root 2. Over here, we have negative 3 times the square root of, and the biggest perfect square inside of 72 is 36 times 2. So we have negative 3 times 6 root 2, or negative 18 root 2. And then you ask yourself, are these like terms? They have the same radicand, the same number under the square root, and they have the same index. They're both a square root, so their index there is a 2. When that happens, it's exactly the same as taking 40x minus 18x, right? Because those are like terms. 40x minus 18x would be 22x. So here, 40 root 2 minus 18 root 2 would be 22 root 2. So just think of that radical, that root, as a variable. You treat it kind of the same way here. All right, let's get a little more complicated since this is honors. For our next example, example 3 says that we have, we're simplifying, right? Simplifying. And we have n square root of 18n plus the square root of 50n cubed minus n times the square root of 192. So your job is to simplify that. All right, take each piece, simplify each piece, and then determine if they are like terms or not. And if they're like terms, you can combine them. So let's take this first one here, and we are going to make this n. And the square root of 18 breaks up to square root of 9, square root of 2, square root of n. Plus the square root of 50 breaks up into the square root of 25, the square root of 2, those make 50. And then here we have n cubed. And so you need to think about what n cubed is. N cubed is n squared times n. So that means that I have the square root of n squared times the square root of n. I don't like that. So, I think I'm going to stop the video and do it again later.